Hello everyone, welcome back to our video class here at CSEC Math Tutor. In this lesson we are going to be focused on enlargement, or bigger topic being transformations, and we have quite a bit of objectives to get through. So we want to describe an enlargement, we want to perform an enlargement using the origin as a center, we want to use other points that are not the origin as center and use different scale factors as well. We want to discuss the relationship between the area of an image and the scale factor. We want to evaluate the scale factor given object and image and locate the center for an enlargement. Quite a bit of things to get through. So let us just jump right into it. An enlargement is sometimes called a scaling or a dilation. So those words work as well. And it is the type of transformation that changes the size of an object. We change the size of the object using something called a scale factor. Now, the scale factor is the magnification of the number we use to magnify the object or to make it smaller. So if your scale factor is greater than 1, your object naturally is going to be, the image is going to be larger than the object because you're magnifying the image. If the scale factor is less than 1, that is, if it's a proper fraction, then your image is going to be smaller than the object because you're going to be shrinking the object. And when it comes to doing them on the graph paper, we use, well, an enlargement must have a center and it must have a scale factor. Those two things are important. For graph paper and for doing the work, the rules are as follows. If we're using the origin as the center of the enlargement, then all that we need to do is multiply the points on our object by the scale factor and we get our image. But if the center of the enlargement is not 0, 0, then what we want to do is to multiply the distance of each point from the center. Let's jump into a question and see how it works. So here we have a triangle ABC with points 4, 1, 2, 1, and 2, 3. Let's just write them down. So our points are A, 2, 1, B, 4, 1, and C is 2, 3. And we are using scale factor 3 first. And so what we're going to be doing is multiplying each of these by 3. We can do that because we're using 0, 0 as our center. So we're simply going to multiply these coordinates by 3. And multiplying by 3 here gives us 3, 2, 6. 3 ones 3. Multiplying by 3 here gives us 12. 3. And multiplying by 3 here gives us 6, 9. So this is A prime, this is B prime, and this is C prime. And we can simply draw it in and look at it. So 6, 3. 6, 3 will be here. 12, 3 is over here. And the 6, 9 is up here at the top of our graph. Let's just put them in terms of ABC. So this is A prime, B prime, and C prime. And let's draw in our triangle. So there we have our triangle, the image of triangle ABC with an enlargement with scale factor 3 and center 0, 0. Now, if we're using a negative scale factor, then we want to multiply these points by -2 because -2 is what our scale factor is. So we're just going to multiply them out by -2. So multiplying by -2, A double prime should give us -4, 2, -2. Multiplying here gives us -8, -2, and here we get -4, -6. So this is B double prime and this is C double prime. Let's mark these points. -4, -2 is here. -8, -2 is here. So let's put them in. This is A prime, A double prime. This is B double prime, our second image. And C double prime is -4, -6. So we go all the way down here for it. And we can now draw our triangle in and look at it and see what's happening. Now, pay attention to what's going on here. Notice that with our positive scale factor, the image is in front of the object. So notice that it's here. The scale factor pushes the image that way. All right? It's bigger and it's in front of it. With the negative scale factor, though, the image is on the other side of the center. So that's important. Here's our center. Let me mark it again. Let me make it bigger. This is our center right here. And the positive scale factor means that the image is on this side of the center. Very important. It's on this side of the center. With a negative scale factor, it's on the other side of the center. So over here. All right. So this is important to notice. Let's look at a different question where our scale factor is a bit different. Our center rather is different. So our center here is 4, 3. Our center there is 4, 3. And what we want to do now is to multiply the distance of each point from the center. So let's look at the distance of x from the center. This is the center. The distance of x from the center is, let's count, 1, 2, 3, 4 units across and 1, 2 units up. So x is 4 units across, 2 units up. And so we want to multiply that by 2. And that would tell us that we are going to go 8 units across and 4 units up. So from the center, we go 8 units across and 4 up. So 2, 4, 6, 8 units across and 4 up. 2, 4. And that takes us to where x prime should be. All right. Next one, z is 8. We just counted that. 8 units across. 2, 4, 6, 8 units across and 2 up. So z is 8 across and 2 up, and we're going to multiply that by 2. So it becomes 16 across and 4 up. So from here, we count 2, 4, 6, 8, 10, 12, 14, 16 units across and 2, 4 units up. So this becomes z prime. And the last one, we count 2, 4 units across, 2, 4 units up. That's y. 4 units across, 4 units up. This leaves us multiplying it by 2 to 8 units across and 8 units up. So we count 2, 4, 6, 8, 2, 4, 6, 8. And so this becomes the image of our triangle. This is y. And so we can draw in our triangle and see what it looks like. There it is. So this is the image of x, y, z, x prime, y prime, z prime under scale on enlargement scale factor 2, center 4, 3. If we use a smaller scale factor, then this is going to result in a shrinking of our object, as we mentioned before. Now let's look at x. X is 4 units across and 2 up. And if we take half of that, then we're going to go 2 units across and 1 up. Let me put that in a different color. And so this is going to be x double prime, second image. And this one was 8 units across and 2 up, z. And if we take half of that, it's 4 across and 1 up. So 1, 2, 3, 4 across and 1 up. That becomes z prime, z double prime. And the other one, the y was 4 across and 4 up, and half of that becomes 2 across and 2 up. And that becomes your z prime. Your y double prime. And so the triangle here would simply be a smaller version of the triangle. But notice as well, even though it's behind the object. This is the object. This is the first image. This is the second image. It's still on this side of the center. All right. Now let's talk about the relationship between the areas of the object and the area of the image. Now here in this triangle, Let's find the area of it. It's a right angle triangle, so it has a base of 1, 2, 3, 4 units and a height of 2. And we can say the area then is equal to base times height over 2, which will give us here 4 times 2 over 2, which is just 4. Let's call it centimeters square. Now, what is the area of this one? So this is 4. What is the area of this one? This one here has a base of 1, 2, 3, 4, 5, 6, 7, 8, and a height of 1, 2, 3, 4. Divide that by 2, then we end up with 16 centimeters square. So there's a relationship that exists between the area of the image, the area of the object, and the size of the scale factor. And it is this. If we want to find the area of the image, then area of image, IMAGE, is equal to area of object times scale factor square. So let's shorten that. Area of image is equal to area of object times scale factor square. Let's try it on that. So the area of our image here is 4. So for this triangle, x prime, y prime, z prime, using this formula here, should have an image of 4 times the scale factor would be what? 2. So it's 2 square. And 4 times 2 square gives us 4 times 4, which is 16. And notice that we got our 16 there. So this is a nice little math thing to remember, that the area of the image is equal to the area of the object times the scale factor square. It would work as well with this one. So the area of x prime, y prime, z prime, that the x double prime, y double prime, z double prime, the area of that should be equal to the area of the object. What is the area of the object? 4 here, times the scale factor. Scale factor is a half, and half square is a quarter, and 4 times a quarter is 1. Now let's find the area of this triangle here. The base is 2, base times height over 2. So the base is 2 and the height is 1. So 2 times 1 over 2, which gives us 2 over 2, which is 1 unit square. But since we're calling them centimeters, fine, 1 centimeter square, as you see. So this is a nice thing to remember, very important, that you can use this relationship to work out different questions. Once you know the area of the object and the scale factor, you can work out the area of the image or twist it around and find other parts of it. So this is pretty much how we do enlargement using a scale factor and a scale factor 2 and a center that is not the origin. So remember now, when the origin is the center, you can simply multiply the coordinates. But if the origin is not the center, as in this case, this is our center, then we have to multiply the distance. So you count the distance to the point and you multiply that distance. All right, now let's look at some questions from CXC that will help us to do some other stuff. So this question is saying that we should locate the center of the enlargement, showing your method clearly. Now, to find the center of the enlargement, what you simply do is that you connect corresponding image points and draw a long straight line through it. So LMN and this image PQR. So this triangle and this is its image after an enlargement. So L and P are similar points. So what you do is that you take a ruler and you just draw a straight line like that through corresponding points. And you just need 2 sets of points. So you can draw it through this one as well. And you notice there that the points intersect at this point here. Let me just draw the other one just for drawing its sake. So you notice that when you draw them, you just need 2, but just to show you that you could draw 3 if you want, but you just need 2. The points intersect right here at this point. And so your center here, the coordinates of this point are 1, 5. And that's how you find the center of your enlargement. All right. So the center of your enlargement, locate the center, and that is the method. So part A, center is the point 1,5. No, it says state the scale factor under the coordinates of the center of the enlargement. So we're going to state the scale factor now. Well, this one is just to locate it. We wrote it down. Let's find the scale factor. Now, to find the scale factor, it's pretty simple. You need to locate two similar sides. So notice here in this question that NM, we're answering part B, NM is similar to RQ. Now, what is the length of RQ? RQ is equal to 1, 2, 3, 4 units. And NM is 2 units. And you simply divide that. So 2 into 4 goes 2, and this is what your scale factor is. You can try it with any two similar pairs of sides. So this side is 1, 2, 3. This side is 1, 2, 3, 4, 5, 6. So you divide the length of the image by the length of the object. Image divided by object, and you get the scale factor. Or you could say then this side here is 1, 2, 3. What do I need to multiply 3 by to get 1, 2, 3, 4, 5, 6? Scale factor is 2. Now let's talk about the last part of the question, which is the area. Determine the value of the area of PQR. That is the area of this triangle divided by the area of that triangle. Remember, we mentioned the formula a while ago. Let me write that in a different color. Area of image is equal to area of object times the scale factor square. So what is the area of this? What is the area of this triangle? Let's look at it. 1, 2, 3, 4 across, and 1, 2, 3, 4, 5, 6. So the area of the triangle is 4 times 6 divided by 2, which gives us 12. All right. And the area of this triangle will be 2 times 3. 2 times 3 divided by 2, which gives us just 3 units square, whatever the unit is. And now we want to divide, we want to write that in this form. So the area of PQR, so PQR is 12 over LMN, which is 3, and 12 divided by 3 gives you 4, which incidentally, the scale factor is 2, and 2 square is equal to 4. So we could have used this to answer it, but because the question wanted you to do some work and write it this way, then go ahead and do it. Find area, put it there, find the area of the other triangle, put it there and divide them out, and you notice that you get 4. So determine the value of that. The value is 4. Let's look at another question. Here we have the diagram below shows triangle PQR and its image P prime Q prime R prime after an enlargement centered at the point C. So this is our center on the diagram. Use the information to complete the statements below. So the size of the scale factor, remember now, we need to compare two similar sides to get the scale factor. So this side here, answering part 1, this side here is 4 units long, so R prime, Q prime is 4 units long, and RQ is 2 units long. And so we divide that. 4 divided by 2 is 2, which tells us that our scale factor is 2. So we can write that in. Scale factor is 2. And now we need to complete the statement. The scale factor is negative because, now notice, and I'm going to skip back a little bit so you can remember. When we use the negative scale factor here in this question, the image appeared on the other side of the center. So a positive scale factor, and the image is on this side of the center. A negative scale factor, and the image appeared on this side of the center. So when the scale factor is negative, the image will appear on the other side of the scale factor. No, sorry, when the scale factor is negative, the image will appear on the other side of the center. Forgive me for that. Now, let's get back to our question. Notice that it says PQR and its image P prime, Q prime, R prime. this is the center, and the image is on the other side of the center. So be, because it is on the other side of the scale of the center, the scale factor has to be negative, and that is what you would write here. The scale factor is negative because the image is on the opposite side, PPOSITE side of the center. And the center here was 4, 4. And that is how we answer that question. Now, 2 more, and then we wrap it up. So on your multiple choice paper, you can expect questions like these. So we have a question here that says, these triangles, ABC is mapped onto A prime, B prime, C prime by an enlargement center O. What is the scale factor of the enlargement? Now, the scale factor of the enlargement, you can simply look at the image and the object. I said look at the similar sides. So CB, C prime, B prime, the length of that is 2 units, and the CB is 1 unit, and so we divide 2 by 1, and 2 divided by 1 is 2. So your scale factor here should be 2. And notice that your image is bigger than your object. So you notice that your scale factor has to be bigger than 1, which rules out these two answers. All right. So your answer here is C. Now let's look at this one. The length MO in centimeters. Now let's look at this diagram. They are similar triangles. This side AB is 6. This side MN is 3. So this one is double this one. So if this side is double this side, notice they're similar triangles, same angles here. So if this side is double this one, then this side has to be double this one. So MO is, using here, we multiply by 2 here to get 2 times MN is equal to AB. So we use the same idea here, that 2 times whatever this is 7. And so 7 divided by 2 will give you the answer that you're looking for. In this case, a scale factor of 2 would take this object here to this image. It's similar triangles, but it's the idea of an enlargement just the same. So 2 times 3 gives you 6, and 2 times 3.5 will give you 7. Remember, you can find a lot more practice questions and practice material at csecmathtutor.com in the past and practice paper pages. Please subscribe, share with somebody who doesn't understand this topic and needs some help with it. Continue to learn and grow as you prepare for your exam, and the best wishes. Thank you for watching.